Alright friends, we are here for another video of Simple Haskell on this Friday night. Well, it's Friday night for me. I don't know about you guys, but I imagine you guys are doing this on Friday night as well. So, I started here by doing a little bit of planning for this video. Just kind of, I figured since this is a more theory-based lesson, it would be better to plan out, and instead of seeing my thinking, just do the full elaboration of what we're talking about here, as you can see with all this stuff, and just go through it one by one, from really what is not higher kinded to what is higher kinded to what is well, I was going to say real here, but this is definitely not real. That is unreal. Just examples of non-higher kinded that we would have talked about in our last lesson. Car, I've avoided actually going into the body of what car is, just because there's no point in getting complicated. Same with int. But neither of these are higher kinded, nor is bool. And then lastly, string either you might think is higher kinded, but in higher kinded you might think because we have a couple different options, and we can see that it's parameterized with a couple different types. Well, I shouldn't say parameterized, but it's using a couple different types. Be the same thing if it was int here, or if it was another string either. This would still be, and by the way, this is a valid type, just by the way. I don't think I talked too much about that in the last video, but even though string either is the actual data type itself, it can still contain itself. The Haskell compiler is smart enough to figure out how to do that, blah, blah, blah. And so yeah, anyways though, even if it was just int here, it would not be higher kinded. And the reason for this is looking at the head of the data declaration. And so if you guys are familiar with lambda calculus, not that it really matters here, but the head in terms of lambda calculus, or really you could just think of this area as being the head. Since we have no arguments here, it is not higher kinded. And so if we have a little tool here called :k, where actually, so I'm going to need to comment this out, and I'm actually going to need to go to main, import kinds, and do right, because I have no implicit prelude, import prelude. Do not worry about what I'm doing there. I am just doing some things to make life a little bit easier. So, easier in terms of this video. I don't recommend doing this. You might notice the no implicit prelude. Normally, prelude is imported, but I am just importing it bit by bit so that I can talk about either and maybe without any annoyances. But yeah, anyways, string either is not a higher kind of type because it doesn't take any parameters. So yeah, and of course now we could make it higher kinded if we wanted to by changing the definition a little bit, but we'll end up with something like either, and hopefully a better way to say stuff. Higher kinded. So first example is this is really the only example of a new type which has a which is higher kinded, and I'm actually come to think of it, I'm not too sure if I even could do. I'm going to try a little experiment here. I want to see, would this work? Yeah. So I guess new types by definition, I never really tried that out, are higher kinded in the, let's call it, first degree. I forget the technical word for it, but it doesn't really matter for actually coding. And if we look at the kind of only case, because I need to reload, we can see this little notation here where it says only case is of the kind star to star. And so you would see a very similar notation for functions, like we had, if I was to ask the type of, let's say, left, for example. If I ask the type of left, and that's, again, just because I'm trying to make my life a little simpler. We're going to look for the prelude left. So we can see that, we have a similar notation for functions. It would be the same for, what is the type of prelude dot elem. We would see, still avoiding type classes, we would see some sort of notation here. But with kinds, we're only ever going to see this this looking thing. And kinds are always communicated to us in stars. And so what this actually means is that only case, like this literal thing, this literal word of only case, is not a valid type to the compiler. So if we were trying to do a function and we said f is a function, my func, we'll call it, and it takes an only case and returns, let's say, a string. This is invalid. The compiler will complain even if I go undefined, which should work for any valid type. I'm just going to say expecting one more argument to only case. So if I was to say instead only case A, right, because this is from prelude, this is really not helping me as much as I thought. Come on. I have to do it here. I guess you're seeing different ways to import stuff. There we go. So now this works because I have parameterized only case in the type signature. And so, at the end of the day, that's what we're trying to use our types for, is for functions. There's no point in just saying, here is a goblin, if we're not going to actually use a goblin in our code, where, a goblin is some type. We're actually going to plan in, the whole idea is to use these types in our code, in our functions, to make our functions more understandable and type safe. So now just continue on. I just wanted to enumerate through all the different options. So of course we don't have to use the new type for a single kind. If we checked out the type of, the kind of example, we will see the exact same output. But now if we try with example 2, well, I didn't really look at it. Okay, well, we're going to see the exact same result. And that's maybe helpful, I suppose. And I guess the point I was trying to make here is that we don't actually have to use, I said this in the last video about just general types, but we don't actually have to use what's in the head. Same goes for functions. Like if I had this only case here, I could have A is what it's called, or my only case. I'm just going to call it that. And I could just return hey. Don't actually have to use it. I can just, say hey. Nothing wrong with saying hey. So now in the case of example 3, what I'm illustrating here is that with this higher kind of type, we can do still whatever with it in the actual body of the data declaration. So we have here example 3a, which parameterizes a, and we have example 3b, which also parameterizes, or is parameterized with a. And, of course, we could have just infinite different constructors that have a. And maybe this is just for some good reason. There is actually a language extension that comes to mind where, well, I guess you don't really need that for that, but there could be a case in which you want to label a specific type in a number of different specific ways, just as a signal to yourself. And then here, again, just as illustrating more about the options that you have with kinds, instead of taking one in the head, we are taking two in the head and just parameterizing it like so. And so if we look at the kind of example 4 or example 5, we're going to see that both of them have these 3 stars. So just like how we had with functions, this last sort of arrow and space is like what's actually returned. So it's something that, like, for example, the kind of bool, prelude.bool, is just a single star. It is a fully applied type, and there is nothing more to do about it. However, with example 5, same thing like with only case, how we have to apply it in order to use it. We have to give it a real concrete type, even if, let's say that, it's a polymorphic type like I was doing there, I still have to do something like this. And I guess in the example 5, I would have to say int in order to actually use it in my type signature. So, yeah. And then I'm really just kind of going nuts and saying, easy as 1, 2, 3. I'm sure everyone gets that reference, but if not, stay with me, I guess. And I'm just, enumerating through a number of different options about A being constructed with with a data constructor A, B being constructed, the type variable B from the head being constructed with a data constructor B, so on and so forth. And then just quite literally going mad with, this guy. For the fun of it, let's say, but why though? And we can see it takes a lot to actually become a real thing. So, and that's a nice concept to think about. Like, with functions, we're always dealing with real concrete types. But what these are, they're often called, the extension, algebraic data types. And that's because, we're doing we're taking these variables from the head and inserting them into the body of the data declaration to create a bunch of new types. And the other maybe better explanation of it is that for something like either, so this is also called a product type. Same with maybe, same with any of these. Anything that is an algebraic data type is largely a product type, or is a product type. And the reason for that is that we are creating new types, like brand new types. These describe how to build some number of types. So, and that's why we wouldn't actually use either, but something like either string or either error and int. Or maybe we would use, maybe the thing or nothing. For example, I use maybe in web scraping quite deeply and quite importantly for my library, Scrappy, which is not a shameless plug, I apologize. And it's just a great tool for web scraping where I can say, in this kind of vicinity of stuff, I either found thing, and I can be as creative as I want with describing such a thing and make that an A, or I found nothing, or not that thing, or not my target. And I don't really, especially in that case, I don't want to know why it failed. I don't care why it failed. I just simply want to know that it failed and then move on. Bon voyage with life. And so yeah, that's really all there is to say about kinds. Can't think I'm missing anything. I also did take the time to think this through beforehand, which is weird for me. So, yeah, that's all there is to know about kinds. Please, as with any other video, feel free to ask questions in the comments, and I will answer every single one. That's not such a big demand as I'm not that famous, so. And of course, comments, critique, suggestions for what you want to see, all welcome, all appreciated. Thank you so much for watching, and please like, share, and subscribe. And yeah, that's all there is. See you next time.